Welcome students. In this semester 6, you are going to deal with the 4 papers again. Paper number 13, 14, 15 and 16. Out of this, we have already seen the topic from paper number 16, that is the sugar industry. Now we are introducing the paper number 14 of organic chemistry. It is also called in CBCS pattern D.Sc.III. And from this paper I am going to teach you the topic natural products. The syllabus includes, this is unit number 4 from the syllabus. The syllabus includes terpenoids, introduction, occurrence, isolation, general character and classification, general methods for structure determination, isoprene, then analytical evidences and synthesis of one terpenoid, that is a citral. Then another natural products, that is alkaloids. Here the points are introduction, occurrence, isolation, classification, properties. Again general methods for structure determinations of alkaloids and study of nicotine. The study includes analytical evidences and synthesis. Let us start with natural products, that is the products of the nature. It is a natural product is a chemical compound or substance produced by living organism, that is found in nature. In broadest sense, natural products include any substance produced by life. They were known to mankind even before the prehistoric days. That is, these natural products were long before knowing to the mankind. A large number of pigments used for dyeing, painting, perfumes and folk medicines were obtained from the plants. These are the dyeing obtained from the plants. In fact, the beginning of organic chemistry was made with the study of the properties of these natural products. They include a variety of both simple and complex organic molecules, and these products constituted the main source of organic chemicals. Number of chemicals are obtained from the natural products. Okay. These are also be prepared by chemical synthesis, both by semi-synthesis and total synthesis. And these products have played a central role in the development of field of organic chemistry by providing challenging synthetic targets. Now these products have also been important to study as they extended for commercial purposes to refer to cosmetics, dietary supplement and food. The produce from the natural source is not contaminated by any artificial ingredient. That is, this is a safe food. Now, why we are going to study natural products? Because they possess curative properties and are of great value in medicines, as some have pharmacological or biological activity that can be therapeutic benefit in treating some diseases. For example, the natural product terpenoids are well-known natural products for essential oils having a strong and pleasant odor. And due to this, these essentials have been used in perfumes since long ago. Another natural product, that is alkaloids. The poisonous and therapeutic properties of various plants have been known, and these properties utilized from early times. The first alkaloid, that is morphine, was isolated in 1817 from the source opium, and it was further followed by the discovery of trypsin, brucine, quinine, which is antimalarial, and many other alkaloids. Therefore, it is important to study of natural products. Now, the first natural product we are going to study is the terpenoids. A mixture of isomeric hydrocarbons having molecular formula C10H16 found in turpentine and many essential oils of plants were called terpenes. C10H16, that is only hydrocarbons, and their oxygenated derivatives, for example alcohol, aldehyde, ketones, were called camphor. Terpenes and camphors are included in a new term and called as terpenoids. Terpenoids are a group of closely related hydrocarbons of general formula C5H8N or their oxygenated, hydrogenated or dehydrogenated derivatives. They are also called sometimes as isoprenoids, as they are composed of number of isoprene units. We are going to see what is this isoprene unit in next. Now, many terpenoids have pleasant smell and therefore they are commercially important in perfume industry and in food industry, that is essence. Some terpenoids are biologically active as insecticides, antiseptic and anthelmintics, that is they are used as biological purpose. Occurrence, of course, they occur widely in leaves and fruits of higher plants, conifers, citrus and eucalyptus. Many terpenoids have been pleasant smell. Okay, we have seen this. And biological activity also we have seen. Okay. Now, representation of structure of terpenes. Now, terpenes and in general organic compounds are represented by condensed structural formula, that is dropping carbon and hydrogen atoms. The zigzag chain or concern ring represents the parent hydrocarbon skeleton. In such a structure, each corner, that is corner, represents carbon. And when other groups or atoms are present, for example, COH group, OH group, oxygen, nitrogen atoms are present, they are shown, while single, double and triple bonds are indicated by single, double, triple lines respectively. For example, the condensed structural formula of some terpenes here given. The first compound is acetoacetic ester. The old way to write, that is CH3COCH2 COOCH5. Here COOCH5 written, the corner indicates CH group. This is C, this is a methyl group, CO. This is a modern way of writing. Yes, the ring structure, these are the bicyclic compounds, alpha, pinene and camphor. Therefore, they are bicycles. Here they have shown bicycles. This is one ring, this is another ring. These are methyl groups and this is a carbon. Now, as they are present in the plant, they must be isolated, and therefore isolation of terpenoids, the method involves two steps. First, isolation of essential oil. Of course, the steam volatile odoriferous oil obtained from the plant source is called as essential oils. Of course, it is extracted from plant material like flowers, leaves, fruit. and it is extracted by any one method. The first one is steam distillation. Here the plant material is softened by soaking in the water, and then it is packed into a column connected with a steam source. That is, from that column steam is passed, and when this steam is passed through the column, the essential oils, as they are volatile, they come out with the steam and collect as distillate after cooling. And this distillate is shaken with petroleum, and finally they distilled under reduced pressure. Due to this, the essential oils are left behind. However, steam distillation may cause the decomposition of some sensitive compounds. Esters are present in the essential oils, giving inferior quality of product, that is raw product, will be obtained. And therefore, so this method is used for isolation of terpenes, that is the hydrocarbons only. Second method is extraction in fat and lard. The fat is warmed to 323 Kelvin and uniformly spread over specially made trays. Now the leaves or flower petals of the plants are spread over the surface, and the tray is kept aside for several days. Now, as the contact takes place, essential oils are extracted into the fat. Okay, the leaves, petals, those are sprayed, are replaced by fresh ones for more extraction. Now, as the fresh ones are replaced, the extraction takes place. The process is repeated till the fat is fully saturated with essential oils. Finally, the fat is agitated with absolute alcohol when the essential oils along with a little fat is extracted into the alcohol. Now this alcohol extract is cooled, the contaminated fat separates out. The terpenoids dissolved in the alcohol are recovered by fractional distillation under reduced pressure. Okay. The most valuable method for extracting essential oils. This is the most method for extraction of essential oils from the plant or flowers of jasmine and rose. And here the yield is also good, that is higher. The next method of isolation is solvent extraction. The plant material is treated with organic solvent like ether or light petroleum at room temperature. Essential oil is extracted into the solvent. The filtrate extract is distilled under reduced pressure to get the essential oil. This is done under reduced pressure because they have volatile compound, and therefore the boiling under reduced pressure is done. And this method is for the isolation of heat sensitive terpenoids in perfume industry. Now, as essential oils are obtained, the isolation of individual terpenoids is done, and it is the individual components of essential oil differ in their chemical and physical properties, and this property is made use to separate them from each other. The first method, the use of chemicals. When essential oils are treated with selective reagents, only specific components react with that reagent. Now they are easily separated and decomposed separately to regenerate corresponding terpenoid. This is a chemical methods used for the separation of terpenoids into their individual one. Here unsaturated terpenoid reaction with nitrosyl chloride, the crystalline adduct is formed by addition reaction, where carbonyl terpenoids on reaction with sodium bisulfite adduct is formed, and alcoholic terpenoids on reaction with phthalic anhydride, esterification takes place, ester is obtained. There are physical methods used for the separation of terpenoids from one another. The physical methods like fractional distillation, of course, under reduced pressure, chromatography, countercurrent distribution are employed in the separation of essential oils. Now, physical methods, these are the first method is fractional distillation under reduced pressure. Okay, this is distillation. Then chromatography, okay, it is done in the adsorption column chromatography, where the essential oils are separated in the columns of adsorbing material, and after eluting the columns, that is a separated material one by one, the solution which is obtained eluent is treated or evaporated to get the solvent, that is essential oil. Chemical method, yes, this is we have to get the essential oils. Chemical methods are also employed. With this, I conclude my lecture. Thank you.